on the course. Galway is reasonable. Yeah, it's a 13,000. That's cheaper than some of the Dublin ones, you know.
It's like 25 or something.
Yeah. Sure, that's better than RCSI. Do you know what RCSI is?
Oh no, I don't.
Wouldn't be too far off 50,000 a year.
55,000 euros.
I thought it was 49. 55.
Last I checked.
Alright, maybe it's gone up. Anyways, any of you thinking of doing engineering? Yes. Any of you thinking of doing engineering, which is most of you or all of you, I think Galway's a great place to be going for engineering. And not only the university, but the town as well. It's a nice town, there's lots to see and do.
More than Dublin?
No, well, depends what you're into. There's lots of cultural things to do in Galway, lots of, events and...
I heard they have a lot of students there.
They do have a lot of students there, yeah. I know Galway's nice. Has anybody been to Galway?
No, we're going on.
Yeah, 24th.
Oh great, you'll get to see it then.
I have been.
You've been? And what you think of Galway?
Okay.
Not bad?
Dublin is much better.
Yeah, well Dublin's much bigger though, you see. Like Dublin's the biggest, so...
Well, I don't think
Yes,
Dublin is like you don't need a ticket for the bus. You can walk.
Dublin's pretty small. I know it's not London, but... Yeah?
I'm thinking of biomedical or mechanical. If it's biomedical, then I'll do it here. Mechanical, I'll do it in the UK probably.
Okay.
Which do you think?
DIT, DCU,
For engineering, DIT.
not DCU.
DCU is okay, of course it's okay, but just for engineering I think DIT would be better. Especially mechanical and biomechanical
I
engineering.
don't think they have it in DIT.
They don't, shame. DIT are good for stuff like that.
Stephen, I
The
want to
engineering
ask
stuff.
something.
Yes.
Do you have any idea what enterprise and computing is?
Enterprise computing. Would that not be
I don't know.
business related? I know there's a certificate called like Enterprise Certificate in
Because when I looked it
Computing.
up, nothing came up. Nothing. And DCU, that's what it offers.
Enterprise
Yeah,
computing.
there's no computer science.
DIT doesn't offer any science, any computer.
No, it does, but I'm talking about DCU.
I don't know. Enterprise computing doesn't.
Open the course from their website and look at the subjects they teach.
I don't want to be in Dublin.
Yeah, that would be the best thing to do. But enterprise computing sounds very business
Yeah.
oriented to me. But what type of computing do you want to do?
Computer science in general.
A general
engineering,
software engineering.
website development, any of that.
DIT not interested?
NUI Galway is my main option right now.
Or Galway, good, and they have it. Good.
How big is it? Is it like really big?
What, Galway?
University?
Galway's a big university, yeah.
In the city, is it like fun?
Oh yes, it's a very fun city. Yeah. It's
Is it all men pub fun or?
no, Galway's a very young city because of the students. Yeah, so Galway would have a good student scene.
And I heard it's much cheaper than Dublin.
Galway is much cheaper than Dublin and Cork.
Yeah, that's why I want to go there.
Yeah.
And plus accommodation is available over there.
Yeah, and like I said, there's a good student scene in Galway, the student town, you know. So there'll be lots of events and things to do going on. Okay. We'll do the circular motion, and then if you have some other questions you want to do from previous lessons to prepare for the test on Friday.
I wanted to ask you,
Yes,
the test that's midterm test,
yes,
that's on Moodle.
yes.
I think one of the answers in the marking scheme is wrong.
The midterm test? Which midterm test?
The first, first semester test.
Oh, possibly. I don't make these tests, they come from... And they have had mistakes in them before. So if you said you found a mistake, I believe that.
Because the question goes like, the speed is 3, then they solve with speed 4 in the marking.
Yeah. That's... Yeah, that does happen, yeah.
But they continued on solving with 4.
It's a typo then, yeah. Let's have a look at these circle questions then. So like I said, because of the university day tomorrow, that means unfortunately we're now going to be 2 classes behind my schedule. But I suppose what can you do about it? Okay. A 10-meter helicopter blade spins at 300 RPMs. how fast are the tips of the blade spinning? Now, when I say the blade is 10 meters, who thinks of it as 10 meters from tip to tip, or each one is 10?
10 radius.
Each one is 10.
Which one is that?
Sure, so.
You're going with 10?
Blade is 10,
Yeah,
so
10
each
is
one is
radius.
10.
Yeah, so the ore is 10.
Yeah.
Okay, now it's, what did I say, 300
Yep.
per minute. So that's 300 over 60 per second revolutions. And how much of an angle is a revolution? 2 pi. So this is the omega. So the V equals omega ore. So that's 300 times 2 pi times 10 over 60. My calculator's not open yet. You have that there? 314?
314.2.
Can we use the V formula, the W formula? Oh, I got it.
Okay, continue. Number 2.
Can I just ask something?
Yes. They just messing with my head. Right, 2. A car turns around a corner and the circle forms is a radius 3 meters. The car is of mass 1500 kg and it takes 3 seconds to turn the corner. What's the centripetal force? Right, so the M is 1500 kg and the radius is 3.
What is the force?
It says what is the force?
Yeah. Sorry, this is me not being careful enough with my English.
So I answered it as friction.
Oh rats, I wanted a number.
I got it.
You got a number? Okay, okay. I'm sorry, I don't know if it's me or English, but maybe I should be a bit more careful with my who, what, where.
Calculate the centripetal force.
Yes. Verbs are good, aren't they? Yeah. Calculate. That's what I was hoping you would do here.
But what is the
But it's funny, no other class has ever... Okay, doesn't matter.
I'm sorry.
Alright.
But it is friction, right? If it was a what? It
Yeah, it would be
It
friction.
would
It would be
right?
friction.
So I am correct, partially.
I'll allow it. Right, so, 3 meters. And what's the time here?
3 seconds.
3 seconds.
Yep.
No.
To turn the corner.
Yes.
So it
So
is
1.5.
No.
No. It is we use the formula for the time taken to.
I don't want to hear your thoughts. I just want a number.
3 divided by 4.
That's not a number. Give me a number.
4 over 3.
No. Where does that come from? No. I understand where this is coming from.
0.75.
No.
12.
Yes.
What?
12. Because if it takes 3 seconds to turn a corner, then the time for one revolution would be 12 seconds.
Wow. This should have gone for friction.
So, F equals MA. What's the M? 1500 A. Do we have a formula for the A?
Yes,
V squared over R. What's the R? 3. So that would be 500 V squared. Do we have a formula for the V?
Yes.
Omega R squared. And what's the R? 3.
4, 5.
So that would be 500 times 9 times omega squared. What's 500 times 9? 4,550.
4,500?
Divided by 3. 4,500. Now, do we have a formula for omega?
4 pi squared. Oh, you wanna, okay.
Yeah, 2 pi over time, which we know is 12. So the answer will be 4500 pi over 6. I know 3 goes into that. 1500 over 3 pi, 500 pi. What's that, about 1600 newtons?
Yes.
So if we're good students, we'll wait until the last moment to use our calculator, which is now. Yeah,
Close enough.
close enough. 1571. I don't know what you're saying.
So the time is 12 seconds.
Yes.
The period. Isn't the period?
Wait, Lee was literally in the middle of asking me a question. Go on, Lee.
Well, find out my uncle's can either like pi or root.
In the exam, they prefer this. In the physics exam, they don't like this, they like this. But in the maths exam, they like this as well. So the physics person in Manchester, he likes to see this as the answer. So you should do it like this. Yes?
I got 4934.8.
I don't think I made a mistake.
No, you didn't make a mistake.
Do you want me to tell you it's okay, don't worry? I can have a look at what you did later to see. Did you do it the same way?
Yes, kind of. I squared the 12.
You squared the 12.
Cause like
I'm sorry, you
the
are
W was
completely right and I'm completely wrong. Dun dun dun. I forgot to
square the W.
the omega here. Okay, we have one student awake. Very good. So that would be 4500 4 pi. Why did I write 2 here?
That's why.
Oh yeah, 2 pi. So that's 4 pi squared over 144. This gives you me the different answer. That's still not your answer though. What's that?
I changed the value.
That's your answer. Good enough. 1, 2, 3, 4 newtons. Thank you for noticing my mistake. However,
No, I just changed the values, so I probably won't tell you wrong.
okay. Can we do the next one now?
So the R is the answer, yeah?
The R's?
Like, because it's V squared over R.
I just replaced the R with 3.
Yeah, it does it. Okay.
Okay. Right. A girl swings a 3 kilogram ball in a horizontal circle of radius 2 by means of a string. Find the tension. So we have the ball being swung around on a circle like this. And what's the mass? 3 kg. And we want the tension force here. So T equals F equals MA equals 3A equals 3 V squared over R. Do we know the R? We do. Do we know the V? No. This equals 3 over 2 omega R squared. This equals 3 over 2 2 pi over T times 2 squared. And what's the T, did I say? 0.25. So I got 3790.
Yeah. This is okay.
Yeah, same thing.
Well, we got different.
Maybe you forgot the square.
No.
No? Right. Continue.
Maybe you're just making mistakes with the brackets.
With the chain, yeah, that's what
they ask for the force.
then you should give the force.
Really?
Yes.
We use the centripetal acceleration.
Yes. For the centripetal force.
Yeah.
Although they might not
They
say
don't
the word.
centripetal
Yeah.
force.
Well, I didn't in my question because clearly that's the only thing I could be asking. But maybe in the exam they'll be more careful
If
and
they're asking for a force in an object in a circle, it's
Centripetal.
centripetal acceleration.
centripetal force.
Yeah.
Yeah. Use the centripetal acceleration. Yeah. Okay. Oh, sorry. Do you need to write this down?
Where did the 2 come from?
That's the radius in the. That's the. Yeah. That form is v squared over r.
Okay.
V squared over r is the a. Yeah. Now, Faisal, tomorrow for the university fair, make sure you give other students a chance to ask questions.
Oh, it's not gonna be like
No, there'll be talks, and then sometimes at the end of the talk they ask if there's any questions.
who's getting the duct tape?
But there's a chance to have a one-to-one chat with everybody after lunch. Yeah. 3790.
Oh, that's a 0? Yeah.
0. Okay. Continue? Yeah.
Is it gonna be free tea and coffee or coffee and tea?
No, it's free. It's free, don't worry.
Just make sure.
That's the main reason I'll be there. Okay. Now, the same one. A girl swings a 3-kilogram ball in a vertical circle of radius 3, and it takes half a second. So this time,
This is MA plus minus MG.
yeah,
Yeah?
why'd you sound surprised? This time,
If the MG wasn't too big.
what's happening here is it's being swung around in a vertical circle. And I want to know what's the force when the ball is at its highest. Let me just write down the info here. R is 3, M is 3, and T is a half a second. Isn't it? No, yeah, 3 and a half.
Or is it 2?
In this one it's 3 now.
Oh, okay.
Yeah. So, which I know actually come to think of it is not realistic because that's one big vertical circle. Right. What is the force when the ball is at its highest? So when it's up here. So if we look at the ball when it's at the top, what forces are acting on it? Weight and the tension in the rope. Okay? What type of force is this?
It's not centrifugal because that's not the type.
You are wrong. It is centripetal.
Really?
This is a
So
centripetal
you
force.
said you were like, don't say
No.
centrifugal.
No, that's no. What I'm saying is centripetal force isn't a force that. Okay, how can I put this? I need an analogy for you. Centripetal force I don't want you to think of centripetal force as like a force like gravity that just appears because there's something moving in a circle. You should only think about it as if something is moving in a circle, then one of the forces must be a centripetal force. It's not, see, sometimes students get this in their head that when something moves in a circle, all of a sudden a centripetal force appears. Sometimes students think that the movement in a circle causes a centripetal force. This is what I was trying to get you not to think yesterday. Instead, you should think one of the forces has become a centripetal force and causes a motion in a circle. But sometimes students think it's backwards, that you move in a circle and this causes a centripetal force. And this is totally the wrong way to think about it. Here, the tension and the gravity have combined to form a centripetal force, causing the ball to move in a circle.
Is it like a part of the gravity?
Yeah, the centripetal force is the tension plus the gravity. The two have added together to form a centripetal force. Do you understand? So, that's equal to F. But what's F? That's equal to MA. But what's A? B squared over R. This looks like the usual story, doesn't it? The V, do we know it? No, so that's omega R squared over R.
Okay, can we cancel the R's now?
Not quite yet, nearly. We change this into M omega squared R squared over R. Now we can cancel.
That's what I did.
Good. Do we know omega? No, but we do know T. Now we know everything. So I get T equals minus mg plus m 2 pi over T squared R. What was the m? It was 3, wasn't it? Oh, sorry, that's a minus, isn't it? Okay, plus 3 times, and it's a square, and what's the radius? It's also 3, and the time is 2 pi over a half, isn't it? No! 2 pi over a half. So this is the tension at the top, 1392.
Just a quick question
Yeah.
for my visualization, okay?
Yes.
We go back to the
Yeah.
to the question, sorry. It says that the girl swings the ball in a vertical circle of radius 3. You said that it's spinning like this.
No, like this. The previous question was horizontal and this one's vertical.
She's standing on a ladder.
Two different girls, right? Sorry.
Yes, yeah. Okay, now the next part is actually easy.
Question.
Yes, yeah.
The gravity and the tension will always be equal in this case.
Equal? I never thought they were equal.
No, I'm asking. In this case, where she's spinning
Yeah?
the top, when the ball is at the top and when the ball is at the
Yeah.
bottom, want it to be equal?
How about you watch me finish the question, then you can ask. Yes? So, when the ball is at the bottom, the only difference is the T acts up and the mg still acts down. So the force, instead of being T plus mg, it will be T minus mg is equal to F. Now, somebody tell me why I said T minus mg and not mg minus T. Not what I want. No,
When you move it, you need to add.
because you don't know what the T is, so you can't know if it's
the
negative.
force acts to the center.
Yeah, you know that the force is acting towards the center, so the T must be bigger than the mg, otherwise it's not centripetal. Okay, so the only difference between these two lines is that instead of a plus we have a minus, which means the only difference at the end here is instead of a minus we have a plus. So then the T at the bottom will be just this, except delete that, and it's a smaller 1451. So the tension is not constant in the string. The string will be tightest and most taut at the top and will be loosest at the bottom.
The bottom has more.
Oh, sorry, I misspoke.
The other.
The idea in my head was right, it's just the words were backwards. The string will be tightest at the bottom and loosest at the top. This makes sense because there's a chance when the ball is at the top that it falls back down. So the top must have a smaller tension than the bottom. Okay. But it sounds like you all did a good job on that. Can we go to the next one? So what's happening in the next one? A boy swings a 2 kilogram ball in a horizontal circle. Its hand is above the center of the circular motion by means of a 13 centimeter string. So the motion forms a cone of height 12 and radius 5. How do we do on this one?
I'm not sure about it, I've got to answer.
So what's happening is the ball is rotating around like this. This height here is 12 centimeters. This one here is 5 centimeters. And this one here is 13 centimeters. And the time, it's 2 kilograms and it's half a second. And what do I want?
Linear speed of
B.
the ball.
Okay. How do we do with this one?
We got the triangle out first.
Yeah, first we resolve it. So we'll have a component this way and a component this way, and this is the t. So this is t cos theta, and this one here is t sin theta, and here of course there's an mg. So you have t sin theta equals mg. Do we know the t? No. Do we know the theta? No. But we could know the theta because we have the triangle.
Yeah.
So the theta is tan inverse,
12/5.
which is, please, do tell.
It's 42.7.
Okay, so this is
So yeah.
2, 9.81 sine
Wait.
67.4. So we have the tension. Uh, 21.25 newtons. Now, if we look at this part, we get t cos theta equals this number times cos 67.4. That's 8.167 newtons. What type of force is this? Centripetal. So you know F equals this. So MA equals this. Do we know the M? Yes, we do. What's the M? It's 2. So A is 8.167 over 2. But A is V squared over OR. What's the OR? 0.05 equals 8.167 over 2. So, if I do 8.167 divided by 2 times 0.05 and then root the answer, 45 centimeters per second.
Why is the t cos theta the force?
Huh?
Why is the t cos theta the force?
I'm not fully awake. I realised I didn't need to bother getting the t sin theta.
Why did you put this as
Because it's the force that's acting.
Oh wait, no, yeah. No, the t sin theta equals mg. I needed to use that to get the t. And then the t cos theta is the one I care about because that's the centripetal force. The vertical force is... The only job of this force is to cancel this force. That's the only job. This one is the one that's making it move in a circle. Do you understand? Yeah?
Why did you put the answer as far as 5?
Instead of...
0 point.
I like using prefixes.
Yeah, I mean, what was the prefix that was in?
It was previously 0.45 meters per second. But I felt centimeters per second would be more appropriate since the information was given to you in centimeters, the length of the string.
So we're not supposed to convert it to meters always We're supposed to convert it to what
Give
is
you answers
in the question.
No. If you give it as meters, that's perfectly fine. And for calculations, you should use meters, like how I use 0.05. But you've got to remember, it's important that as an engineer, you present the answer in the way that the reader is expecting it. Because if this person is dealing in centimeters and they ask you for the speed, they probably want the answer in centimeters per second. Not that 0.45 meters per second is wrong, it's just you can prevent a lot of misunderstanding by giving people the information in the format they're expecting, you know. So this is all I was trying to achieve with this. Yeah. Okay? Alright. Now time for the juicy question. Now Lee said he got the answer, but I don't know if I believe him. Do you have the answer written down? Oh, how convenient. How convenient. Anyone else do it? No one else wants to claim that they did it, but the answer's just at home?
I did actually do it.
And you get
Trying to do it, but no luck.
tried and failed.
Yeah.
Anyone else?
That would never show up in your exam, yeah?
But it's still a very interesting question, because as Faisal said yesterday, you have no information. If you look at the question, a very small smooth marble is placed on top of a very large smooth boulder. The marble rolls along the boulder and leaves the boulder at what point?
What's the boulder?
Just a big rock. So, let's have a look. We have our... Actually, so I thought there'd be time to do other questions, but this worksheet is taking so long, I don't think there will be. So we have our very large boulder, and we don't know the radius, but we'll just give it some radius. We'll call it r for the moment. But we don't know what it is. Actually, you know what? I'll go with small r. Yes? What's wrong?
No, I just got the idea, I think. Now. Yeah.
Okay, whatever. So, you have the little marble here, and it's going to roll off, and then of course at some point it leaves. So, it's kind of, this angle is really what I want to know. Okay. At the very beginning we say it's at rest, and here it's moving with velocity v. So what type of energy does it have here? Potential. And what about here? Kinetic and potential. The potential at the start is mg, which is 2r. Here's the ground. Okay. And later its kinetic is a half mv squared plus the potential, which is mgh. Now the problem is we need to know what the h is, which is this length here. Yes? Now we can know this much. What's this length here? Here to here. R. So we just need to know this one, right? How big is this?
God knows.
No, we do know. R, yes, yeah, yes. So this is r and this is theta. How much is this side? Or sine theta. And this side? Or cos theta. So the height is r plus r cos theta. Here. Let's put that in. We get 4 mg r equals a half mv squared plus mgh, which is r plus r cos theta. Like this. That is an excellent question. 2 mgr.
Thank you.
Now, the m's cancel. You know what? I'm one step ahead of myself. We'll multiply everything by 2. So we have 4gr equals v squared plus gr plus 2gr plus 2gr cos theta. Now we can do some cleaning up, because what's 4gr minus 2gr? 2gr minus 2gr cos theta equals v squared, right? Is that okay? So I just took these two to the other side. Right, now, let's examine the forces here closely. What forces are acting on this? Weight of mg and
Reaction.
a reaction force acting out like this. Okay, let's resolve the weight here. So the weight acts in two parts, one this direction and one this direction. Now I know the diagram's getting a bit messy. If that's theta, I think I'll have to draw it again over here. If this is theta and we have a force here and we want to resolve it in this direction and this direction, if that's theta, then this one here, theta. So if that's mg, this one here is mg cos theta, and this one here, mg sine theta, and this force here is or. Which is the centripetal force in this diagram?
mg cos and
Yeah, mg cos and, go on, Andrew? Yes, how do I combine it here? Minus or. F is ma. Yes? But what's the formula for A? V squared over the radius, which is small r. So let me just pull that over into the main problem here. So we have now, this is like one result, and now we have mv squared over r equals mg cos theta minus r, from looking at the forces. So I'll multiply everything by small r and divide everything by m. So cancel, and here over m. And then I'll multiply by or, cancel, or. So now I get, yeah?
It's done before the R.
This one is another or, reaction.
Oh, yeah.
V squared equals gr cos theta minus or over m. However, at the point when this leaves, the or becomes 0. But or equals 0 at the exit.
Least theory.
Yes, Lee's theory. So we get v squared equals gr cos theta. Now, do we have a formula for v squared already?
Yeah.
If we put these two equations together, we get 2gr minus 2gr cos theta equals gr cos theta. 2gr equals 3gr cos theta. What can I cancel? Cos theta equals 2 over 3. So theta is cos inverse 2 over 3.
That's easy, it's right.
Yeah, what did you say the answer was, Lee? I think you said 47 earlier, wasn't it?
Yes, it has
8.
48.2 degrees.
Yeah, this one's probably.
It's on the Irish exam for...
Even if it comes, I will.
That's the reason I put this in here, because I remember this was on my exam for high school.
That was a good exam.
Did
Huh?
you do it?
I can tell that was a good exam.
Good year.
Did you do it?
You managed to do it.
No, he didn't. That's why he got it back so he could laugh at us.
Yeah, maybe I couldn't do it. I need closure on it now. So it's an interesting question because, as you pointed out, you're given no information, and yet I can tell you the angle that it will leave. It will leave at 48.2 degrees. Now, what might also blow your mind, if there's time to blow your mind, if this was on a different planet and the G was different, how would this answer change? Would it increase or decrease?
Stay the same.
Would stay the same. Not only did it not matter the size of the boulder, it doesn't matter what planet it's on, because, do you see in this step here,
Yeah, we can't.
They cancel the G's anyways. So if this was done on the moon, it would still exit at 48.2 degrees.
So no matter how big the circles are.
No matter how big the boulder is, or how weak the gravity is, or how strong the gravity is, it will still exit at 48.2 degrees. Yes.
For every object.
For every boulder
Boulder,
situation.
circle,
Yeah.
circle.
Because again, the answer does not depend on the radius. It did not factor into the answer. There's no or in here. Neither did G factor in. Neither did the M.
Does the speed affect the answer?
Do you mean will
The V.
the V be different? Yeah. So although the angle is the same, I expect in the moon situation the V, when it exits, to be smaller.
So where did you get the 2 and the 3 from?
What do you mean? From this line I just brought the tree down.
No. Like, where did these...
Oh, where does it come from? There's nothing about the problem that makes it the 2 or the 3. It's not like, oh, it's 2 because there's 2. Well, actually, yeah, I do wonder if it's the 2 because I have 2 oars here. If it was a semicircle, no, it'd be the same. It would be the same.
Hit the ground before leaving.
No, because 45 degrees is here.
Yeah.
Oh.
No,
So it might be 1 over 1.
no, the answer wouldn't change if it's a semicircle. That's interesting. Anyways, what? If it's a semicircle, it doesn't, because it will still exit before the end. In fact, it could even be cut off a little bit because you have up to this angle before it exits. Yeah. So, but I mean, this is important from an engineering point of view, because if you think about it, imagine you were designing something, some curved top. Just 1 second before you go. If you were designing some curved top, okay, if you had the curved top like this and the water's running off of it, it might, you might have sort of a spray effect as it runs off the edge. But if you know the angle is 48.2, then when you make the curved top, what you could do is you could just have it cut a little bit so that this angle here is 48. So it means this is when the water would try to exit. So then you could put the gutter around the edge here. So the water, you know that the water will still be on the boulder when it gets to this point, because it's only after does it exit. So you could catch all the water while still having a curved top, you know. If you cut it too much, like a full half a circle, then when the rain falls on it, you'll have this kind of spraying effect. You know? Now, you might say, well, so what? Someone gets sprayed or something. Well, it means that this part will stay dry and this part will stay wet, which means this part will wear down faster than this part, which means the top will be a different colour than the bottom after 20 years. You know, this is real life problems. Alright, we'll wrap it up there, so